everybody should have paper out. Everybody should be drawing this. Whether you are a visual learner or whether you are an auditory learner or whatever, to be completely honest, in this case, I don't really care. I want you to do this with me right now, okay? Because if you don't go through the process, then it's very, very hard to understand how to do this, okay? So a friendly reminder that we have a box that sits at rest on a rough 30-degree inclined plane. It says draw the free body diagram showing all of the forces acting on the box. And then there's some math to do. So we'll do that in a minute, some physics and math. So yesterday we drew the free body diagram with 3 forces acting. So just to kind of remind us here, we had this one here. What was this force? Frozen. Oh, I'm frozen. Okay. There you go. What is that force?
Gravity.
Gravity. It's the force of the Earth acting on the box, right? Pulling straight down. Other forces that you have acting on the box. What else did we say? The surface acting on the box, right? The surface goes this way. Okay? And there's also a surface going this way, right? 2 surface forces. One is the normal force. Normal is always what to the surface? Perpendicular. And the frictional force is always parallel to the surface and opposing the motion. Yeah, okay. So those were the 3 forces, the ones that I've highlighted in pink, yellow, and blue. Okay? And then we wanted to know what to do with this situation. So we actually finished part A quite a while ago. Now it says, if the box weighs 150 newtons, what is the coefficient of friction? You said, well, that's a good question. How are you going to figure that out? What's that?
Wait, I think I have an idea. It'll be.
Well, say it. Nobody else is saying it.
Okay. So, it's not moving.
It's not moving.
So
I'm going to write that down because that's important to know.
So the force of friction has to be counteracting whatever else is going that way. So it has to be counteracting Fn, the normal force.
The frictional force is counteracting the normal force? Is that what you're saying? I just want to make sure I'm understanding what you said.
Yeah, I think I said that wrong. But it has to be counteracting gravity.
The force of friction is counteracting gravity?
Yeah.
Yeah. So the force of friction is pulling up the ramp, and gravity's pulling
down a little bit.
Down a little bit and in a little bit, right? It's doing kind of both. But yeah, it does. Yeah. So it's not moving. We know that the force of friction and the...
Wait, so it has to be equal to FG parallel, right? Because the 2 F's are parallel. It has to be opposite, sorry.
So like if you're going to write an F-net equation,
yeah.
I feel like that's kind of what you want to do, but you just haven't said it. Is that true?
So F-net has to equal 0, and it has to equal FG parallel plus FF.
How do you all feel about that?
Yeah, I agree.
Gary, was that, you had your hand up a second ago. Did you want to say something else, or was that kind of where you were going as well?
Yeah.
Okay. So I agree with that. That's a true statement. How's that going to help me figure out the coefficient of friction?
So you can determine FG parallel because you can determine FG sine theta.
Okay.
And then with that you can find FF.
Okay, so this is FG sine theta. I'm just trying to kind of understand where you're going with that. Is that a true statement? Is that what you're saying?
Yes.
Okay. So you can say that FG sine theta, like this one's going to be a negative,
Yes, it would.
and this one's going to be a positive. So FG sine theta is negative, so FF is equal to FG sine theta. Is that okay?
Well, like the
Negative.
The magnitude of it?
Yeah,
Okay.
magnitude, yeah. And then, so you can find the force of gravity by the 100-foot.
Wait, there's an F.
You do 150 times.
But that's where you have the math. It's already.
Can you do?
Oh, wait, you can find them.
Yeah, can't you?
Wait, just.
Well, it's just FG. FG sine theta. It's just like the.
What does it mean? What does waves mean?
Weight is the force of gravity on.
So it's.
So F. Oh, wait, it's associated.
Okay.
Mm-hmm.
So you know.
Yeah, so we take FG times sine of 30. Then you make that negative.
Okay.
Sine 30 is 1/2. No. Sine 38 is 1/2. Yes, 1/2. Okay. I think I can do math. So that's 70, so it's negative 75 is FG, so then FF is 75.
So let me pause there for a minute to make sure that other people are on Jacob's wavelength there, because I want to make sure that you're feeling okay. Do you guys follow what just happened?
A little bit, yes. Actually, I don't.
So the net force is 0 because it's not moving, it's not accelerating. You were just looking at the stuff that was parallel to the surface. So FG sine theta and FF, they have to be equal to each other since they add up to 0. That 150, it's not a trick, but it's just we got to pay attention, right? But it's 150 newtons. Newtons means that it is a force, and it says that it weighs that much, so that's going to be your FG. FG sine 30 gives you that. What's up?
So right above like the 150 newtons sine 30, the thing about it, why is there negative?
Because y'all told me that this was going to be the opposite of this.
It's just like,
It's just signs. So as long as you're okay with the signs, I'm okay with it too. Yeah. Does that make sense?
I get it above, but I thought like,
well, like
if you were to move FG sine theta to the other side, then you'd be.
Yes. So the value of this is negative, and that's negative, so the negatives cancel out to make it positive. So this value is positive.
it's just because like when something's weighed, it always is like a positive value, but really it should be negative.
But FG really equals negative 150 newtons.
Because, yeah.
No, that was okay. I was not explicit about it, and I appreciate your asking that. Yeah. So am I done?
No, you find the coefficient.
I need to find the coefficient of friction. So you've been narrating the whole story, but I want to make sure everybody else gets to play. So can somebody else help me do the narration? Go, yeah, and then I'll come back to you too. Is that okay?
So the coefficient of friction is mu, right? So then it's mu equals FF over Fn.
Mm-hmm.
And you know Fn, since the net force is 0, in the y direction, because it's not accelerating, you know the Fg, or you have to find Fg perpendicular, and it's going to equal your Fn. And then you already know your FF, and then you just find it.
Okay, I'm going to add a couple steps in there, but I think I understand what you're saying. So the net force is going to be adding all the forces that are acting in one direction, Fg perpendicular and Fn. So there's those two orange ones that go up like this. Okay, so these two pieces add up to this one right here. Right? So these two pieces add up to this. That's where my Fg perpendicular comes from. Fg perpendicular plus Fn has to add up to 0 because it's not accelerating. Not moving, not accelerating. So I'm with you so far. Okay, so then we're going to call this one negative. We'll call Fn positive. So Fg perpendicular, how do I find the value of Fg perpendicular?
It's one.
The cosine.
I think I heard you, but I couldn't. Oh, because you were doing. Yeah.
9.9.
Yes. So 150 times. Can I just write that as the cosine of 30? But yes, it is root 3 over 2. I'm there with you. So Fn equals, do you have a decimal value for that?
129.9.
What was it?
129.9.
Thanks. Okay. And so then we can say that mu is equal to 75 newtons divided by 129.9 newtons. Now, I was just going to say, there's one piece that we didn't say in here, and that was that it just barely sits at rest. If I made it a little bit bigger, then it would slide down. Yeah, so thank you for asking about that, because that was not explicit in the question, yeah. Just barely not slipping. Yeah. If that's the case, then the value of mu is, go for it.
I was gonna ask.
Yes.
So it's like at the max static.
Yes. Yes. Yeah. And I did not say that explicitly, so I apologize. That was my bad in writing the question. Yeah. Yeah. Do you guys have calculators out?
Oh.
Because you wouldn't need a calculator out. What's that? 0.577. What are the units?
There are none.
Okay, good. All right.
That's easier.
So hopefully that kind of made some sense. Let me give you another one for you to do. Okay. So really I don't want you to determine the normal force, I want all the forces. Determine all the forces acting on a mystery box while it sits on a ramp at a 25-degree incline. Okay? Can you do it? Yes, Miss Cartman, we got this. Go ahead and give it a shot. If you get stuck, let me know. I'll help you out. I want everybody to play. Three-body diagram. On an AP test, you could draw the incline, I think, if you want. But if you included the components, if you include the components, they'll count it wrong.
Really?
Yes. So FYI, so that you know.
Can I draw it then erase it?
So this is what you do. This is what one does.
Okay.
So they'll say, draw the three-body diagram on this dot, right? And then they might give you like the line, so that you have that kind of to measure from. Draw the three things you need there, right? 1, 2, 3, and label them and all of those things. But then draw yourself a separate diagram. That's the diagram you actually use for the problem. Does that make sense? So this is the one that you use to make AP happy, and then the one that you break it down is the one that you actually use. Yeah.
So what should the size of those arrows be?
That's a good question. This one should probably be a little bit bigger, huh? Let's take a look. So when we do this, so this is the AP version, right? So if I'm going to do this for myself, FG is going to be broken down into FG perpendicular and FG parallel. And so FG parallel has to counteract FF, and normal force will need to be counteracted by FG parallel, or perpendicular. Does that answer your question? Yeah. Question?
So when you're answering this, even though you have to find FG parallel and FG perpendicular, you're going to find it as an answer?
Correct. So if this was an AP question, or even a question on a test, it would be more explicit than this. It would just say, what are the values of FG, FF, and FN, or whatever. Yeah. Or some, you know what I mean? Like it wouldn't be so vague as to leave it all open there. So did you find the values?
Yes, we did.
Okay, let's do it real quick. So FN was 88.8
newtons.
Confidence.
confidence helps, right? FF
41.4 newtons. Confidence, okay.
and FG
98
Newtons.
we're okay? Awesome. All right. We're gonna let's see. How much time are you gonna give me here, Lizzie? Not very much, huh? We're gonna start. I don't know.
Can I ask you a question about homework problem?
Sure you can.
Let's see, wait, do you have a book?
I do. Hold on just a second. It is chapter 5, problem 34. Let's do it quick.
Is that what we got today?
I forgot. Well, it's just from I don't remember when it was assigned, like, because I put them all kind of in other spots.
Last night.
I apologize. Let's take a look at it. It says, a vendor at a local art fair ties her tent to a concrete-filled can, as shown in the picture. A stiff breeze comes, and the string becomes taut. What is the maximum value the string tension can have before the can slips? The coefficient of static friction between the can and the ground is 0.6. All right, so I'm going to start with a picture. So there's the can, and there's a force that's at an angle of 40 newtons, actually no, 40 degrees. Force of the string on the can. Are there any other forces acting?
Gravity, normal force.
Okay, so you got FG pulling down.
Is F string an applied force?
Yeah, or it could be there's another one we haven't really talked about yet, which is tension, but it doesn't really matter. Do you want to call it applied force?
Yeah.
Okay, let's do it.
It makes me feel better.
Yeah, I think there's friction.
Well, it says that there's a coefficient of friction.
Okay, so yes.
So I imagine there probably is friction. Which way is the friction going to pull or push?
It'd be like, so left, 2D.
Yeah, because the ground is this way, right? And friction always has to go parallel to the ground. So it's going to go something like this. And then am I missing anything else?
Normal force.
Oh, no, normal force, yeah. That probably doesn't need to be that long, does it? Nope.
I guess I shouldn't have looked at the description in the book, like for the answers in the thing, because that made it really confusing.
Is this okay so far?
Yeah, well, I think I understand how to do it now. Like, I mean, you can keep going through it, but I know where
So I would take this blue force and I'd break it into an X and a Y. And add up all the X's and add up all the Y's. Does that kind of make sense?
Mm-hmm.
And you know that FF is going to be mu times Fn. Because that's that like just before it goes, right? Because it's less than or equal to mu Fn. But we're talking about just before it blows. So that means that we're going to be at equals to. So you're going to find normal force, adding these two, and don't forget that one. Right, when you add them up. So this one here, and then the force of the string in the Y direction. And then you've got the force of the string in the X direction. Mm-hmm. You want to work on it a little bit more and then let me know if you are still stuck. Does that sound okay? Time-wise, just because Lucy's going to get mad at me in just a second, I think. Is that true? Yeah. Yeah? Okay. All right. Okay. We good to stop for a second? All right. So, on Friday, you all